In this video, I will show you how to set up the Karman Vortex simulation experiment, which is Lab 6 for Mechanical Engineering Lab 1. Once you open the case file and set your solver processes as shown in the instructional PowerPoint, you will want to change a few settings, which I'll show right now. You want to make sure that your solver type is pressure-based, so you'll just click pressure-based. Time you want to make sure is transient. And then for the three states that we're going to be investigating, laminar, transitional, and turbulent flow, you'll want to change the viscosity and the velocity. So to change the viscosity, you'll go to air like I just did and type in whatever value shown in the table for transitional flow, which will be the state that I'm showing in this video. You'll want to put 0.0084 kilograms per meter squared, or per meter second. And then after that, you'll do change/create. Since I did not make any changes, I will close. And then to change your inlet velocity, you'll open up inlet and then click inlet here. Double click it, and then you'll type in your velocity. For transitional, will be 1 meter per second. Click apply, and then close. After that, you'll want to make sure that you have your directories all set up. So for that, you'll scroll down here to the solution drop-down menu and then go to calculation activities. You'll have your automatic export here, edit it, and then browse for whatever file you created or folder that you want to store it in. And then you want to make sure that velocity magnitude and vorticity magnitude are selected over on this right side. And then click OK. After that, you'll want to initialize your simulation, so you'll double click initialization. Make sure it's standard initialization, and we will compute from the inlet. And then x velocity should be the value of velocity that your state will be. So like I said, for transitional will be 1 meter per second. And then you initialize. Make sure that you select inlet and then do initialize. Okay. And then after that, you just go to run calculation. All these settings are shown in the PowerPoint, so you'll want 800 time steps, a time step size of 0.2, max iterations per time step of 20, 1 reporting interval, and 1 profile update interval. After that, you'll click calculate, and the simulation will start running. This will take a little bit, and then once that's done, you can start getting your results in CFD post. And your residual should look something like this. After opening CFD post, you should see a screen like this. At this point, we'll create our contours, so you'll go up to the contour button, click it, and name it, let's say velocity for this contour. And then you will want to select all domains. The location should be symmetry 1, variable should be velocity and a global range, and then number of contours should be 150. And then click apply. And then you can generate your first velocity contour. And you can save a picture by right clicking and clicking save picture. Next, you'll want to get your vorticity contours, which will be done the same manner, just changing your variable to vorticity and then clicking apply once again. But first, you'll have to change your range to user specified, and you'll want to change your minimum will be kept at 0, your maximum will be increased to around 1/10 of the way down on the slider, and then we can click apply, and you'll get your vorticity contour. After this, we'll want to make an animation, so this will be an animation of the vorticity contour plot. So we'll go and select the time step animation option. And then once you select that, you'll specify the range for animation. Start time step should be 550, keeping the end time step at 800, and then you'll want to select where you want to save it. And then you'll click play to start running it. After the animation is complete, you should have a fully working video of the animation as shown here. After this, you'll perform the same simulations and get the same contours and animations for laminar and turbulent flow.